The United States Air Force has long relied on three major defense contractors, Northrop Grumman, Boeing, and Lockheed Martin, for its advanced aerial combat needs. But since the launch of SpaceX in 2002, Elon Musk has introduced a new kind of competition, one that's now reaching into the world of military aviation. Fast forward to 2025, and SpaceX is reportedly developing a next-generation bomber aircraft for the U.S. Air Force. Could this be the future of strategic bombers? Might it even spark a new global arms race? Traditionally, top-tier aerospace projects have been dominated by veterans like Lockheed Martin's Skunk Works and Northrop Grumman. But SpaceX, with its rapid innovations and bold ambitions, is changing that dynamic. Elon Musk entered this field not through aircraft, but by revolutionizing rocketry, cutting costs, introducing reusability, and pushing boundaries. What started as a dream to transform space travel has evolved into a serious partnership with the U.S. government. Through government contracts, SpaceX began launching military satellites and payloads for the Pentagon. As their capabilities expanded, so did the Pentagon's expectations. With the development of Starship, capable of reaching Mars, discussions reportedly shifted toward creating high-speed, long-range military aircraft. Some suggest this includes a new bomber concept that could rival, or even surpass, legacy aircraft like Boeing's B-52 Stratofortress or Northrop Grumman's B-21 Raider. The logic is straightforward. If SpaceX can send spacecraft to Mars by 2026, why not develop bombers that fly faster and farther than anything in service today? While SpaceX has never built a weaponized aircraft, its increasing involvement in defense signals a major shift. Now, with Elon Musk holding significant influence in Washington as head of the Department of Government Efficiency, he's reportedly greenlit development on a bomber project that could redefine modern air power. Still, there are questions. Elon Musk is an innovator, but can he lead the development of a strategic bomber? And how would it measure up against proven platforms like the B-52? To understand the challenge, it's important to look at what SpaceX is up against. The Boeing B-52 Stratofortress is a Cold War giant, a symbol of overwhelming power and long-range strike capability. Introduced in the 1950s, the B-52 shattered expectations about what bombers could do. With its ability to fly at high altitudes and carry a massive payload, it became a psychological weapon as much as a physical one. One of its most famous uses was in Operation Linebacker II during the Vietnam War. From December 18th to December 29th, 1972, the U.S. Air Force launched a major bombing campaign using B-52s to pressure North Vietnam into peace talks. More than 20,000 bombs were dropped on key military and industrial targets, and marking the largest heavy bomber campaign since World War II. The show of force broke North Vietnamese resolve and pushed them back to negotiations. So, how did the B-52 come to be? It began on November 23, 1945, when the Air Materiel Command issued requirements for a new long-range bomber that could operate without relying on overseas bases. The Air Force wanted an aircraft that could cruise at 34,000 feet, carry a large crew, and deliver heavy payloads, including multiple 20mm cannons and over 4,500 kilograms of bombs. Several companies competed for the contract, including Boeing, Consolidated Aircraft, and Glenn Martin. Boeing won with a $1.7 million grant to build a full-scale prototype of the XB-52. Although development faced early hurdles, Boeing eventually delivered an aircraft with the right mix of range, payload, and performance. The B-52 featured swept wings, pod engines, and crew ejection systems. There were also several variants, each with slight design changes. For example, the B-52D had a mix of upward and downward crew ejection systems, but the tail gunner had to manually escape, making survivability low. By the time the B-52G arrived in 1958, safety had improved significantly, including better ejection options for the entire crew. Yet, even the B-52 wasn't without flaws. Structural fatigue became a major concern. Repeated stress from low-altitude flight, necessary for tactical missions, caused cracks in the airframe. Flying low increased maneuvering and stress on the metal, leading to wear and tear far beyond that experienced at higher altitudes. These issues limited the bomber's lifespan to around 2,000 flight hours before requiring major repairs. Despite these challenges, the B-52 remains in service today, testament to its versatility and power. For SpaceX to compete, it would have to not only match but exceed the B-52's capabilities in speed, range, payload, survivability, and cost-effectiveness. So the question remains, can Elon Musk's vision of a next-gen bomber truly take flight? And will it redefine the future of aerial warfare? So, in the early 1960s, the United States Air Force created the high-stress program as some sort of checkup program for every B-52 bomber that had been in the sky for over 2,000 hours and was surely going through some structural fatigue. Once they looked through the B-52s that had flown over 2,000 hours, they check which one needs to be fixed, and they have stronger pieces added to the body of the bomber, giving it a bit more leverage to fly for that long. As time went on, the Air Force got even craftier with the creation of wet wings attached to their G and H models of the B-52s. They were called wet wings because they were capable of holding way more fuel than the other models. However, that compromised the structural integrity of the bomber jet even further. The added weight on the wings from the fuel forced the wings to bend out of shape, and they got 60% more fatigue than the B-52D. Once again, the need arose for a solution. So, they created the ECP-1050 as a replacement for the wet wings, which increased the durability of the jets and reduced the percentage of quick wear and tear. But there was something more about the bomber, as its sheer size meant that it couldn't perform huge spins or a loop-to-loop like a fighter jet could at an aviation show or in combat. Although the yaw, pitch, and roll were added parts to the bomber plane, it was not built to move like a stunt plane. Instead, the flight controls were focused on vertical stability, even though it has a relatively small, narrow-chord rudder, giving it limited yaw control authority. It was almost like having a giant school bus big, powerful, and built to carry people and heavy ordnance. The B-52 bomber was a force in the sky. But by 1977, its airframe showed signs of fatigue under high-speed conditions, prompting a structural upgrade known as the Pacer plank rescuing. Despite the wear from flying near Mach 1, the U.S. Air Force continued to rely on the B-52 for wartime missions, thanks to its impressive payload and performance as a bomber, outclassing its predecessors. The B-52 was optimized to carry up to 20 Boeing AGM-69 SRAM nuclear missiles, air-to-surface weapons designed to destroy Soviet surface-to-air missile defenses. With a range of 110 nautical miles and advanced targeting, they gave American bombers a better chance of breaching enemy airspace. To further boost defensive capabilities, the B-52 was later equipped with air-launched cruise missiles, LCMs. After testing both the Boeing AGM-86 and the Navy's General Dynamics AGM-109 Tomahawk, the Air Force chose the AGM-86B for the B-52. Over time, continued upgrades, especially under the Conventional Enhancement Modification (CM) program, gave the B-52H an expanded arsenal. These upgrades included underwing pylons from the B-52G, integration of the Harpoon and HAVNAP missiles, and compatibility with newer weapons like DAMs, WCMDs, AGM-154 glide bombs, and the AGM-158 JSSM missile. Despite its legacy, the B-52 is no longer the future of American air power. Though still active, its role is slowly being replaced by the Northrop Grumman B-21 Raider, the next-generation strategic bomber built for modern warfare. The B-21 Raider represents a leap forward. Developed under the Air Force's Long-Range Strike Bomber (LRSB) program, it's designed for stealth, long-range missions, and the delivery of both conventional and nuclear payloads. The project began in 2011 when the Air Force called for a faster, more capable bomber. After a competitive bidding process, Northrop Grumman secured the contract in October 2015. Boeing and Lockheed Martin, whose joint bid was rejected, filed formal protests. But in October 2016, the Government Accountability Office upheld the decision, citing cost as the key factor in choosing Northrop Grumman. Now tasked with delivering a bomber that combines intelligence gathering, battle management, and interception capabilities. Northrop Grumman faces a major challenge, but also an opportunity to redefine the future of air warfare. A new generation global precision system now guides the deployment of bombs, nuclear warheads, and various payloads. While India is nearing the launch of its sixth-generation fighter jet, the United States is on the verge of unveiling the world's first sixth-generation bomber. 5 years after awarding the contract to Northrop Grumman, the U.S. Air Force released new renderings of the aircraft. The images revealed a smaller, lighter design than traditional bombers, featuring flush blended inlets and a two-wheel landing gear, unlike anything seen before. Compared to previous bombers like the B-2 or the massive subsonic B-52 Stratofortress, this aircraft hinted at a future where stealth bombers could be more compact and efficient. A year later, Darlene Costello, Acting Assistant Secretary of the Air Force for Acquisition, confirmed that the first two B-21s were under construction at Plant 42. On December 2, 2022, the first B-21 Raider was officially unveiled at Northrop Grumman's facility in Palmdale, California. At the event, Northrop CEO Kathy Warden stated that the B-21 was built with modular open systems architecture, allowing for easy upgrades and potential export of components. This approach contrasts sharply with older jets like the B-52, which used closed systems that made maintenance and upgrades difficult. With open architecture, parts can be swapped out like pieces in a Lego set, avoiding full disassembly. Although it might be assumed the first aircraft would be a prototype, the Air Force confirmed that the test model would be upgraded to an operational bomber after test flights concluded in 2023. Late that year, successful fueling and engine tests cleared the way for a low-rate initial production, LRIP, contract awarded to Northrop Grumman in January 2024. This marked the beginning of a limited production run, with the B-21 expected to enter service in 2025. Meanwhile, rumors have surfaced about Elon Musk developing his own advanced bomber, allegedly backed by the Pentagon, though details remain unconfirmed.